Hello boys and girls, so we proceed to 3.8. We have potential divider. So what is actually means by potential divider? A potential divider actually is a circuit that will divide the voltage between two or more resistors. So basically the main purpose we have potential divider is we use to obtain smaller portions of voltage from a single voltage source P. For example, you have a source voltage of 240 volt, but then you just only need a very small portions of voltage. Let's say you only need 24 volt to charge your power bank. So you have to obtain a smaller portions of voltage, 24 volt from this voltage source 240 volts. So how we are going to obtain small portions of voltage from the large voltage source? We are going to use potential divider. So boys and girls, how we are going to obtain smaller portions of voltage from a single voltage source? So this is done by connecting two or more resistors in series, because we learned this before in learning outcome 3.5. We know that when resistors connect in series, the voltage will be shared among the resistors. So, for example, I have two resistors connect in series, R1 and R2. So, I'm going to connect it to the single voltage source V. So, this is a complete circuit. I assume the current flow through the both resistors is I. So, the voltage across the first resistor R1 is V1. The voltage across the second resistor is V2. So, we can see very clearly the voltage V, the source voltage, will get split or divide into smaller voltages V1 and V2, okay, across R1 and R2. So, since the current flowing through each resistor is the same, so we understood current for series combinations is always the same for both resistors. So how I'm going to get the value of V1 and V2? So we can apply the Ohm's law, V equal to IR. So when we rearrange, current will be the voltage divided by the total effective resistance. Okay, so V over the total effective resistance for these two resistors connect in series will be R1 plus R2. So I put this one as equation 1. So therefore the potential difference or the voltage across R1 will be V1 will be current multiplied R1. So just now we already get the equation for current, so we put the equation 1 into equation 2, so we can determine the voltage across the first resistor. V1 will be R1 over R1 plus R2 multiplied the total voltage V. Similar goes for V2. So V2 is IR2, so when we put equation 1 into these equations, so we will obtain V2 will be R2 over the R1 plus R2, the total effective resistance multiplied the total voltage. So in general, if the potential divider have n resistors connect in series, so if we have more than 2 resistors connect in series, we can obtain smaller portions of voltage, for example, across R1. So how I'm going to determine the smaller portions of voltage across R1? So the V1 will be R1 over R1 plus R2 plus Rn multiplied the total, the source voltage V. So be careful. Okay, so R1 plus R2 plus until the n resistor, that one actually is referred to the total series resistance. You can recall the concept in series. For series combinations of resistor, we just need to total up all the value of resistance to obtain the effective resistance. Okay, so or we might also apply the ratio of V equal to ratio of R in order to determine the value of V1 or any small portions of voltage that across the resistor. Okay, because voltage is proportional to the value of resistance. If the resistance in the circuit is large, normally it will have large voltage across it. Compare with the small resistance. If the value of resistance is small, then the voltage across the resistance also will be small. Okay, so I show you one example how we are going to calculate the small portions of voltage from a large voltage. So for example, I have this circuit as my potential divider. I have a total voltage of 12 volts. So the 12 volt is the total voltage. Then this voltage is connected to two resistors, 3 ohm and 2 ohm. So I want to find V out. So V out will be the smaller portions of voltage. Which we want to determine. So how we are going to calculate the output voltage, these small portions of voltage. So we are going to apply the concept of potential divider. We understood that the 12 volt will be divided in between 3 ohm resistor and also 2 ohm resistor. So we can apply the equations in potential divider. So I denote this one as R1. So the V output I denote as V1. So 3 ohm I denote as R2. So in order to get the V output, so this V output is across 2 ohm resistor. So I'm going to have 2 over the total or effective resistance of the circuit is 2 plus 3. Then the total voltage is 12. So I'll get the V output is 4.8 volt. It means that I'm going to obtain 4.8 volt. A small portions of voltage compared to the total voltage 12 volt. Okay, so this is one of the alternatives. Another alternative to solve the problem, you might use the ratio V and ratio R. So 12 volt is given to two resistors, 3 ohm and 2 ohm, 2 plus 3. And then the V out is only across resistor 2 ohm. So I use the ratio. So I'm going to have 4. The V output will be 4.8 volt. Okay, so if you want to use the equation, also can. Or you might also use the ratio V and R in order to solve the questions about potential divider. So before I end these sessions, I show you actually where we will use the potential divider circuit. Okay, for example, actually we use the potential divider circuit, or we call it as voltage divider, whereby we can get a voltage that depends on temperature. For example, we might replace one of the resistor with thermistor. Okay, so this thermistor will change the resistance depends on temperature. So the voltage will increases or decreases with temperature. So we can connect the output of any of these circuit into a comparator to check it is above or below a certain voltage. So then we can do something based on that. For example, if the temperature is above 40 degrees Celsius, then we might turn on a fan. Okay. Then the second one, we might also use the potential divider, or we call it as voltage divider, to monitor the changes in light in the room, whereby we might replace one of the resistor with photoresistor. Normally the photoresistor will change the resistance based on the amount of light it detects. So this way we can have a circuit that increase or decrease the voltage based on the light detect lah. So, nilai resisten akan berubah mengikut cahaya yang dia dapat kesan. So, bila nilai resisten berubah, voltage output yang kita dapat juga akan berubah lah. So, you can have a circuit that increase or decrease the voltage based on the light. So, we can use it to turn on a light if the voltage indicates that it is dark, the room is dark. So, we can use it to turn on a light. So this is the example of how we apply the potential divider circuit in our daily life. So this is the concept we have for potential divider in learning outcome 3.8. So you might try tutorial question 13 to check your understanding about the potential divider concept. Okay, then I'll see you in next video. Bye bye.